So as we move on to lesson 5.1, today we're going to do with, I said the learning goal is to be able to set up our own system of equations to problem solve, and then use those equations, get them in, ready to graph, and use the graph to help us answer the questions. So, number one, several books are on sale at a bookstore. Some of these books sold for $3, while others sold for $5. One day last week, 80 books were sold. The total amount of the sale was $300. How many of each type was sold? So, remember when we did the tickets, the adult tickets and child's tickets problem, when we did the coin problem, some were dimes, some were nickels, there were two unknowns. In this problem, there really are two unknowns. We do not know how many $3 books were sold. We do not know how many $5 books were sold. We do know how much each of those books sold for. We do know how many books were sold altogether. We do know how much money was taken in altogether. So I've already chosen for us, would you put a box around this? This is kind of, this is what you're going to have to do every time you do a problem like this. You're going to have to first describe what are the two unknowns and which variable is going to represent which unknown. So I have chosen that X is going to represent the number of $3 books and Y is going to represent the number of $5 books. Well, then on our graph, it's got to be the same thing. On the x-axis, we have to have the number of $3 books. On the y-axis, we have to have the number of $5 books. So now we're going to set up two equations to help that are going to work together as a system to help us solve this. So I have written a couple of sentences here with a little bit of mathematical symbolism going on in it that should help you set up equations. Go ahead and try to set up two equations. The first one being the number of $3 books plus the number of $5 books equals the total number of books. So in other words, books plus books should end up being books altogether. They can't become something else. So go ahead in that white space right underneath that sentence, write an equation that we could use to represent that. And then our other sentence is the dollar sales of $3 books. How many dollars are taken in selling the $3 books? Plus the dollar sales of $5 books. How many dollars are taken in total for selling just the $5 books? Add those together, it should give us the total dollars of sales. So you should be able to write an equation for that one also. Go ahead. So in the white space under this one, write an equation so that we have our system of equations. And then off to the side over here, we're going to write it as a system with our big, fancy brackets. So what's one of the equations that we're going to be able to use to problem solve this? Eddie?
3x plus 5y.
3x plus 5y. That's not an equation yet. You got more? Well, when we take 3 times x, what are we getting? $3 times the number of $3 books. What are we getting?
The total.
Isn't this right here, that 3x, isn't that this part right here? The dollar sales of $3 books, when you take $3 times the number of books, let's say it's 10 books. If you took 10 times 3, would you have books? 10 books times $3 each? No, what are you going to have? Money. You're going to have how much money was taken in sales for $3 books. So 3x represents the amount of money taken in for the selling of the $3 books. And then he has a 5y. I'm going to guess that would be a good representation of the total dollars taken in selling $5 books. Well, then what should we set that equal to? What was the total sales? $300. So one of our equations is 3x plus 5y equals 300. Money taken in for $3 books plus more money taken in for $5 books should equal money in the end. And then what's another equation that we can have for this one? Cameron? You can write another one down? Macy?
3x plus 5y equals 80.
3x plus 5y equals 80, so that would be this one right here. Okay, do we agree? Not everybody. Benton, do you want to change that somehow?
X plus y equals 80,
Why should we change it to x plus y equals 80?
because the 3 and the 5s and y's and how much the books were worth.
Yeah, remember, taking 3 times x gives us money. And so we can't add money to money and get books. Not gonna work. So Benton's right. What we need to do is we need to make this the number of $3 books. We called it x right up there. We called it that. Plus the number of $5 books, y. We called it that right away in the beginning. Books plus books equals books, 80 books. So our other equation is x plus y equals 80. Okay, let's get ready to graph them. So we have our 3x plus 5y equal to 300. We have to get the what alone? The y alone. Go ahead and do that. Get the y alone. What do we have to do first? Subtract the 3x. We want the y's alone. What's our next move? Divide by 5. So 5y. The 300 has to get divided by the 5. The 3x has to get divided by the 5. All 3 pieces have to get divided. So what's our equation now? Read.
Y negative 3 plus x plus 6.
Also known as, yes, you had it right, Hayden, negative 3/5 x plus 60. So what's our m and what's our b for that one?
M is negative 3 plus b is 60.
Okay, before we can graph this, we need to get our coordinate plane set up. So what did we call the x-axis again? What are the x's representing? Because we need to label our axes when we know what our number of $3 books. So let's put under there that this is representing the number of $3 books. And you can't just say books. You have to say it's the $3 ones. So our x-axis is representing how many $3 books are sold. Our y-axis then would be the number of $5 books sold. And then notice I've chosen the scale for us because I knew that if I just left it and we went by ones, it probably wasn't going to work out very well. So what's the scale I've chosen for the x-axis? What's every grid line going to represent? 5 of those $3 books. What's every grid line on the y-axis going to represent? 5. So if you want to, you need to number it out so that you can, whoever looks at your graph can read it nice. But if you don't want to have to show every single number, instead of labeling the next grid line 10, you can skip over it and just do the next grid line, which would be 15, even though we know that that grid line in the middle represents 10. Okay, so go ahead and get both your x and your y-axis labeled so that they're going to be useful for somebody to read this graph, including you. Oopsie. So if we were to label the very outer edge, how many dollars worth of books would that, or how many books would that be, not dollars, but how many books would it be? 100, yeah. Okay, so now go ahead, after you've got that done, go ahead and get your graph made for this one before we move on to the other one. So both of them will go up to 100. Out to 100. So where are we starting at? We're starting at 60 on the y-axis. our slope says -3/5. Now, when we're going 3 up or down, and we're going 5 across, left or right, are we really going 3 units? How much are we going? Let's say we go 3 down. 1, 2, 3 grid lines down. How many books are we really going down? 15. If we go 5, then we've used up our negative going down. If we go 5 grid lines over or to the right, how many $3 books are we really going? 25. 5, 10, 15, 20, 25. Is 15 over 25 the same as 3/5? Okay, as long as it's the same thing, it's just another name for it, we can do that. So we're going to go down 3 grid lines, and we're going to go over 5. And just keep doing it until you have at least 3, but I would say let's just do it until we meet the x-axis. Now tell me something about when we draw the line through these points, would it be a line with arrows at both ends? How about at the left end, going up here to the left? No, why not? What's happening when we go this direction? Negative number of $3 books. How about when we go down on the right-hand side? What would happen when we get down here? Be a negative number of $5 books. So what are we going to do? We're only going to draw a line segment actually because we know what these numbers are representing, so we're just going to connect what ends up being our x and y intercept points. Okay, now we're going to take that other equation, x plus y equals 80, is that what it is? Okay, and we're going to get the y alone. This one doesn't take very much to do. And identify our m and our b for this one. So what's our m for this one? What's our m? -1, okay. And our b? 80, okay. So of course, to make that into a rise over run, we could put it over 1. So now we will go and put our first point at 60, or at 80, excuse me, not 60, at 80. When we go down 1, how far, what are we really going down? 5 books. When we go over 1, what are we really going? 5 books. So is 5 over 5 still 1? Yeah, so we can still get away with that. I'm going to say, because we're just going such a, keep going, just keep making points until you can see where they meet, especially on these. If you don't take the time to do that, you're going to have a harder time telling where these guys are going to meet. So just keep doing it until you can see the actual point that they share in common. Make lots of points. Okay, here I give you a spot where we can say our solution. So what is our ordered pair solution? Where are they? What's the ordered pair name where they are intersecting? What is it? 50, 30? Okay. Everybody agree? 50, 30?
Yes. Wait. Yes.
So that tells us what? How many of the $3 books were sold? 50. How many of the $5 books were sold?
30.
30. Now, when I say check our answer, here's how we're going to check our answer. In other words, does our answer make sense to what the setup was? Not according to our equations. We're not going to check them in our equations, because if we set up the wrong equations, it's probably going to check out. But what's the information they gave us in the beginning? So this is 50 books and 30 books, and they're supposed to add up to 80, because there were 80 total books. So, you know what? That does happen. That makes sense. The other thing they said is there was $300 in sales. So if we take 50 times the number of, or the price of the $3 books, so we have 50 books that are $3 a piece. We have 30 books that are $5 a piece. What do we get? What's 50 times 3? 150. 30 times 5. 150. 150 plus 150. 300. And is that what the total sales were? Was $300? So our answer makes sense. Our books add up to 80. The number of books add up to 80. The dollars amount taken in by each of them add up to the total of $300. Questions on this one? I want you to the back side then. I want you to start reading that column and deciding what do you think X and Y are going to represent, because I didn't tell you this time. Read the problem to yourself and decide what should X and Y represent, because that's always what you have to do first. So in other words, what are the two unknowns? What are the two things that we have control over? Anybody think they know? It's one of them, maybe. The number of people. Yeah, how many people are you going to invite to your Super Bowl party? Okay, so let's let X, because how many people you invite kind of sounds like it should control something. You get to decide how many people you're going to invite. Well, then what would our other unknown be? Or in other words, what would this control? What can change based on this?
Cost.
The total cost, right? Not just cost, but the total cost. We know how much they charge each of them per person. We know what their one-time fee is. We already know that. We don't know though how much it'll be total until we decide how many people are going to be invited. So let Y represent that total cost. Remember, our dependent variable, Y, depends on our independent variable, X, the one that's in control. Okay, now we have to set up an equation using our X and Y. And sometimes, in situations such as this one, you can kind of pit one against the other. One of them has their own equation. What would it cost you to go with Budget Burger for your party? The other one, how much would it cost you to go with the Viking room? So what equation could we use that would represent how much it would cost us to go with Budget Burger? What equation could we use there? Tate?
Y equals 120 plus 10x.
So not even looking up at the paragraph above, I'm going to say the total cost for me to decide to go with Budget Burger is $120 one-time charge and $10 for every person. Is that what it is? Okay? Now go ahead and write one for the Viking room. What's it going to cost if we chose the Viking room instead? Got one for me, Elizabeth?
Y equals 150 plus 8x.
Okay, without having read up above, this tells me that the total cost to go with the Viking room would be the $150 one-time charge, and they charge $8 a person. Is that right? Okay, so do we have a system of equations here? Yeah, you know what, let's just put our little fancy bracket right there. Those two equations working together will help us determine that, because the question is, or we're told to do, find the number of people for which the total cost is the same for both. You know what? In other words, if I just want to flip a coin to decide, how many people should I invite then? Because then it won't matter dollar-wise. Okay, are they both ready to graph? Are they both in graphing friendly form, in other words? Yeah, so let's just get their Y's and M's identified. Or they're Y's and M's, they're B's and M's. And if you're starting to graph this one, you might regret it because this is going to be a little tricky. Okay, you may be erasing. Okay, what is the slope and y-intercept for our first one here? 120 plus 10x. Slope is 10, and the y-intercept is 120. Okay, and our other one, our slope is 8, and our y-intercept is 150. Okay, let's go down and look at our graphs before we start graphing. What's going to be on our x-axis first of all? We got to have a title there.
People
No,
are
Number of people. Number of guests, if you want to call them that, whatever. It's not
Peeps, not peeps.
the restaurant.
Not peeps.
What's the scale on the x-axis? It's going by
Total.
ones. The x-axis is going by one person at a time. So let's get that numbered out. Hayden. Okay, Hayden, what's the title on the
Total
y-axis?
cost.
Total cost, yes, not the other restaurant. And what's that cost in dollars, pennies, dimes, nickels?
Dollars.
Dollars. Okay, so we say dollars. We don't have to describe how we're going to count people. We do have to describe how we're going to count money. Okay, and what's the scale on the y-axis?
20s.
It's going by 20. Every grid line represents $20. So we need to number that one according. Be really careful, double check yourself to make sure you're doing this right because you don't want to throw yourself off when you're graphing these. So if you're skipping grid lines like I am, you're actually doing every 40.
Why are you going over 40?
Because I skipped a grid line. So the next grid line after 20 would have been 40. So then I did 60. 20 plus 40 is 60. Okay, we are ready to maybe graph. Let's try. So for the first one, our B value is 120. That's easy enough to do. There it is, nice and easy. Okay. Its slope is 10. So that would mean 10 over 1. But are we going by 10s on the y-axis? No, and if we went up 10 grid lines, how much would we really be going up? Not $10, but 10 times $20. We'd be going up $200 at a time. If we go up 10 grid lines, that's really $200. Well, if we go up 10 grid lines, and we only go over one person on the x-axis, is that the same thing? No. So we have to make it equivalent. So if we're gonna have to probably rename this, so give it a different name that is equivalent to 10, but would help us be able to do this slope a little bit easier. So since every grid line is representing $20, isn't 20 a multiple of 10? So couldn't we take this slope of 10 and rename it? So m equals 10 times, what would we have to multiply 10 by to get 20? 2. So we're just going to rename it. But if we multiply the numerator to rename it, we also have to multiply the denominator by the same thing. So now we have 20 over 2. Is 20 over 2 still 10? That's just another name for 10, so it's legit. So now when we do it, we're not going to go up 20 grid lines. What are we going to go up? 20 dollars. So we're going to go from 120 to 140. And we're going to go over 2 people. Well, those are going by ones. So we're really, in reality, look at what's happening here. We're only going up 1 grid line and over 2. That does not mean the slope is 1/2, no. Because they have different scales, we have to adjust accordingly. So when we go up $20, we're really only going up 1 grid line. When we go over 2 people, we are going over 2 grid lines. Go make a whole bunch of points like that. Now you can just go up 1 and over 2 and keep making points. Now you don't even have to process. Should this one be a line segment? What should it be? Array. This one should be array. Because in reality, it has to start out here at the y-axis. But nothing says it has to end at you having 20 guests at your party. If you want to have 20,000 guests, feel free.
That's a big house.
Okay, so we have that one graphed. So now let's move on to our other one. Anybody have any questions on that one before we do try the other one? Okay, let's do the other restaurant line. So we have a slope of 8, which we can put over 1. We have a y-intercept of 150. So we'll go to 150 on the y-axis. Now we can't fudge that. We're going to have to go halfway between 140 and 160, right? So it's going to be right there, halfway between 140 and 160. Make sure your y-intercept's in a good spot. Okay, if our slope is 8, if we want to go up 8 grid lines, we truly want to go up 8 grid lines, can we just go over 1 grid line? So can we go up $160 for every person? No, this says it's $8 for every person, not $160 for every person. So what could we rename? Let's rename 8 over 1 now. So M equals 8 times, what would be a multiple? Remember, it's going by 20s. So think of a multiple of 8 that 20 would go into. 80. Or think of a smaller one if you want. 40. So we can multiply by 5. So if we multiply the numerator by 5, we have to multiply the denominator by 5. And we're going to rename our slope as 40 over 5. 40 what again? That's $40, not 40 grid lines. $40 for every 5 people. So we're going to go up 40, so we're going to go up, well, if we go up just to that one, it's $10, 30 over halfway between again. So we're at $190 and over 5 people. So I went up $40 from $150 to $190 and over 5 people. Now I got to go up $40 again, which would be up to $230 and over 5 people. And we haven't really met another point yet. It's close to it, but it's still not there. Now we have to go up another $40 and over 1, 2, 3, 4, 5 people. And now I would say I'm feeling pretty confident I'm on my line. How about you? Are you feeling confident you're on that other line?
Sure am.
Because we're going to check our answer out anyway. So I'm right here, and I'm going to say this is my ordered pair choice. You decide if it's yours. So this ordered pair says, let's see, 15, and I'm at 270. You agree? That was yours? Your papers also? This is why it's so important to make so many points, draw good lines, so that you're going to be able to make a good estimate. But we're just estimating right now. I think it's ordered pair 15 to 70. So now what I'm going to do is I'm going to go, when he invites 15 people, the total cost should be the same. Doesn't matter which restaurant I go. So that's the even out. Doesn't matter which one, I can flip a coin. Or I can ask my best friend that I'm inviting and say, which you get to pick. But we're only having 15 people because then it doesn't matter which restaurant we go to. So now let's check that out. Let's see if it. So we want the cost to be the same. So if we do it with Budget Burger, the first one, what did they charge? What does Budget Burger charge? $120 plus $10 a person. And we are inviting 15 people. Let's see how much it costs for that one. So it's 120 plus 150. Cost is 270. This is BB, Budget Burger, right? Okay. Now I'm going to come over here and do the Viking Room. What does the Viking Room charge again? 150. And they charge $8 a person, and we have 15 people we're inviting. So 8 times 15, well, 8 times 10 is
80.
5 times 8 is
40.
80 plus 40 is
140.
no 120. We don't need a calculator.
I have it.
150 plus 120.
290. Oh, I put 140 down, I'm sorry. 270.
So if you invite 15 people, is the cost the same at both of them?
Yeah.
Yeah. So do we have a good order here solution?
We do.
Yes, we do. Okay. Now, sometimes they ask us to do that. This. Explain when it is cheaper. I forgot to draw my line in that last one, didn't I? Okay, let me go do that. Stop. Explain when it is cheaper for Derek to hire Budget Burger to cater his party and when it is cheaper to hire the Viking Room. So in other words, less than 15 guests, more than 15 guests. Which is going to be cheaper when it's less than 15 guests, and how can we tell? How does the graph support that? When is the cost cheaper? Is it at Budget Burger or Viking Room? When? Because remember, at 15 guests, it's the same. So let's go look at our graph here. Right here, this is when it's the same. Look at before that. Let's look at it before that. Which one's cheaper? Which line shows cheaper cost? The higher one or the lower one? The lower one. This is as it's going up. That's the money part. So which one of these is this one? Is this Budget Burger or the Viking Room? That one's Budget Burger. So we would say Budget Burger is cheaper for less than 15 guests. The line is below up to the intersection point. So we were looking for the cheaper one. It had to be below. Which one is below? Up till we get to that intersection point where they are the same. Well then, as we keep going with our Budget Burger line, which is the red points, is it still cheaper once we get past the point of intersection? Are the red points still lower? No, they're higher now. So which one's cheaper at when you do more than 15 guests? If you want to invite the whole freshman class, which of the places should you have cater the party? The Viking Room. So we're going to say the Viking Room is cheaper for more than 15 guests. The line is above, or excuse me, is below the intersection point beyond it. So in other words, once we get to the intersection point and look beyond it, that's when it's below. I don't know that I worded that really well, see if you can do a better job. Okay, so sometimes you have to do some analyzing also from what does your solution, what does the graph actually show, okay? Okay, so anybody have any questions on being able to set up and what the expectation would be for that? Setting up your own system of equations? Let's look back at both of them. What do you absolutely have to start with before you write your equations? What am I gonna say needs to be shown?
X, Y.
What do X and Y represent? Don't just write equations with X's and Y's in them, without saying what your X and your Y's represent. And what else did we do in our graph that was really important?
Bunch of points.
Give title to the axes before we made a bunch of points.
Good.
Okay,